my session is basically going to focus on to enterprise mobility, and then I will be having some references to Android, what Android offers for enterprise mobility users in terms of developing the applications. And then there is a specific aspect of it which I will dive a little deeper, and in the interest of time I know that I cannot run through each and every slide in detail as much as you would like me to go through, but I would make sure that towards the end I will dedicate 5 minutes for question answers, and if still the time, if time is not sufficient, we will run over offline question answer session, so please feel free to reach me. So as I said, we will be covering enterprise mobility at a glance. We will be briefly discussing about Android OS security being the topmost priority in the enterprise, how exactly Android scales up to that expectations, and what as a developer we can do to make sure that those enterprise expectations are met. And then again, I will just give some theoretical touch base upon what are the best coding practices for enterprise in terms of developing for Android platform. And then there is a very important aspect of enterprise mobility, because enterprise being something that is already existing in terms of a bigger infrastructure that you are extending it to your mobile devices. There is something called as MEAP, which is Mobile Enterprise Application Platform, which helps you extend your existing infrastructure applications to a bigger set of devices providing the mobility. So this is how I will be going through the sessions. So I know everyone knows the mobile devices. I'm sure everyone has, like maybe 90% of you have the smartphones. One thing that I would ask you, and raise your hands if you have answer to it, how many of you really use your mobile phones or keep your mobile phones closer to you almost all the time? I know some people who don't even leave that phone when they are going to restrooms or even when they are sleeping. How many of you keep it closer to you? Almost full house. And that's the power of this mobile smartphones or tablets in terms of reaching to the mass. And basically mobility is nothing else but the capability or the ability to communicate or reach to more number of people and giving that freedom to work from anywhere. I'm sure being developers, we all would love to work out of cafeterias or maybe our homes or I don't know, some other places. And that's all that we want. And more the freedom we have been given, more happier developers we are. The same is with the executive management or top level people. They would like to be in control of the data, communication, workflows all the time. And mobility is all about giving that channel or that means to the people who are going to make the difference in the enterprises. So this is just a formal definition of enterprise mobility. Now, if we look at from the enterprise mobility in terms of, I'm not sure why the screen is not being refreshed. Okay. So what is actually happening in the corporate world? Basically, the enterprises would like to have their applications which extend their existing enterprise data, which would be something like you have your internet websites, your leave management systems, your approval rejection processes, your reimbursements, stuff like that, to be able to be accessible through the entire network. All the employees should be able to access it. The second one is the corporate communication. Most of the applications fall into the content or transaction workflow based or analytical report based applications, which are basically applications such as extending your SAP or ERP platforms or CRM platforms, making sure that your Salesforce, your the actual customer focusing team gets access to all the vital information. And then there are some applications which are like telecom expense management, such as like making sure that all kinds of expenses that you make in the telecom or on your devices and all that are being tracked. And there is a very important aspect that is coming up for enterprise applications, which is basically customer outreach, like kind of branding applications. So imagine you have heard about Boeing 787 Dreamliner, and now Boeing makes an attempt to make sure that it gives you an application that you can download and play around with that, which tells you what exactly that Dreamliner looks like, its history or stuff like that, which is like basically a brand building application. Or if you look at it, some of the very luxury cars like BMW, Mercedes, they have their own applications which allows you to customize the accessories, just put on various different accessories and look at it like how they look like, what my car is going to look like, what color combinations I can make up. So these kind of applications which drive the data or take the data from backend systems from the enterprises, which could be like maybe parts, inventory, maybe some accessories and stuff like that. These are basically kind of applications that we would be having. And then if we have to look at like a security aspect in the enterprise applications, there are three areas where we will focus on to security in the enterprise applications. One being that application level, the other one being at device level, and third one at the network level. I will explain how exactly is this. Application level in the sense like having proper mechanism into your applications that conforms to your enterprise policies such as single sign-on, making sure that you draw your authentication details from the Active Directory, you look at the data which defines who you are, what your role is, what kind of profile you have, and based on that it gives you an access to the functionality that you intend to perform in that particular application. The other one being device level, like you must have heard about like devices being jailbroken or rooted and things like that. So how do you ensure that your very important vital data which is from your enterprise, like some of you must understand the data which is related to pricing, competitive information is very, very important and it must be safeguarded. So your application has to make sure that it also employs some sort of device level security precautions that it does. And the third one, least but not the last, is network level implementation. While the data is in transit, like because you have a device, you initiate some action, and by the time it reaches to the server or at the end where it is supposed to be, that channel has to be absolutely secure. Then there are various ways, and we'll just touch base upon like what are those and how we can do it. But these are the three important aspects of security. And if I have to dig a little deeper, then there is infrastructure, and then there is middleware, and then there is applications. If you look at all these three and take care of these three aspects, probably you have covered like 80–85% of the entire enterprise application requirements in terms of what your system admin team says, what your policy says, what your customer brand, what kind of activities your enterprise stands for. You can justify all of them if you take care of these three aspects into your applications. And again, security being a key focus areas, it is our first and topmost priority to implement each and every requirement of security defined by our organization into our application. May it be about your password, whether your password could be only text or only numbers or combination of it or whatever it is, you will have to do that. If your single sign-on requirements tells you that it has to authenticate with the Active Directory or maybe RSA key tokens, or it has to go over the VPN, yes, you will have to adhere to those requirements. And then there is the mobile middleware platform. And again, I will go into the details of this later on. The mobile middleware platform, basically, it helps connect various different backend systems to your application or solution offering, such as imagine you have an application that is residing onto a tablet or onto a smartphone, and you store some information or you need some information, maybe related to stock or maybe inventory back of the system. Now this request has to go to some server. Some server has to talk to your authentication services, your data services, your business logic. That business logic has to go back to the server systems, wherein it goes and pulls in the data from probably SAP database, or it probably goes to any other ERP or inventory based systems, pulls in that data, does all the logic, and then gives you the data. Now imagine as a developer you will have to hook your application to SAP database, PeopleSoft database, Oracle ERP database. Would we be able to develop all those kind of interfaces just like this? Probably not. So you need some sort of layer in between which will help you connect to all these layers seamlessly in terms of web services, in terms of consuming their default whatever mechanism, like whether it is a JSON web services, whether it is a normal HTTP communication or TCP communication or maybe SAP BAPI calls or whatever it is, whatever it could be. That layer has to facilitate this so as to, as a mobile developer, I don't have to rely upon what kind of interfaces are being made available or what kind of like backend system it is. All that I care about is the customer, the user experience onto my device, making sure that the experience that I'm going to offer to my users in terms of enterprise application is done without having any deviation. So I don't have to worry about what server side stuff is. All I care about is the application. And this application, note that not just the resident client application, but could even be a mobile website. A resident client application is something that you install it onto your device and then it stays there, which you can launch and you can play around, which is rich in graphics. In the morning, like some of the speakers explained us what is the difference between a web application and a resident client application. And then there could be thick client application, there could be thin client application, there could be a hybrid application, blah, blah, blah. I'm not going into those technical jargons. But all that we need to remember is that as a mobile developer, we need to focus onto a mobile application or a mobile website. I don't want to care about the backend systems. This is all that middleware platform should be doing it for us. So all the legwork of pulling that data in the right context is something that application is going to do, or that layer is going to do. And again, as an application security, we have to care about like these four important aspects again. One is the user authentication. And again, as I told you earlier, based on your enterprise policies, you would go to various different agencies or various different locations to pull in all this information. Active Directory, RSA key tokens, and whatnot, LDAP servers and things like that. Data security on device, and I will again, when I come to Android, what security model it employs and how it supports enterprise applications, I will explain this again in little detail. Data in transit issue, whether you want to do HTTPS only communication, on top of that you want to do any other different data encryption or maybe a different kind of de-identification of the data while in the transit. This again depends on the kind of application that you are looking at it. For example, if you are looking at like kind of salary or payroll applications to be extended or timesheet applications, probably you don't want to encrypt all the data, but you just want some basic information to be encrypted so that that thing is not stolen or that thing is not spoofed around. These are the things that you would worry about. And other very important aspect, your application or the device has to conform to the standards of mobile device management and application provisioning. Mobility is all about being able to work remotely. So if I ask you, take your device, hook it to a computer and then install the application, it's not going to work. So over the air provisioning of the application is very important. And on top of that, you need security to the devices. We are so used to carrying all these fancy devices, smartphones and all that. Who will ensure the security of these devices? When it goes like when I go onto the airport and while checking out and say for example I just leave it at the security desk and that's it. Somebody gets hands onto it. Even though I have a password, that there are like brute force that can be applied and then you can crack my device. What happens to my data? What happens to all the important information sitting onto it? So if you have some sort of like mobile device management policies in place, and then there are again specialized softwares that come in which you can deploy as part of like IT system admin tasks, which will make sure that with some remote commands you can simply wipe out the data. And then there is a very fantastic feature onto Android how you can do it, and I will again come back to it. Again, just to recap, the mobile security considerations, if I have to translate into different terms, it goes to access, storage, and transportation. Access is all about like applications, storage is all about like what you store offline or while doing the transactions, and the transportation is while it is in the transit. And then this is, again, these slides will be available for all of you to download, so I'm not going into the details of each and every one of these. I want to give more opportunity for questions. So let me just quickly tell you, these are various different data access security mechanisms, including storage, transmission, or how exactly you can implement some of the tips and tricks. And each bullet of this, if you just go to Google, you will get hell lot of information onto it. But then again, this is just to give you an idea of what that security is and how vast it is. Now, just to recap everything in enterprise mobility and security, the topmost thing that we will have to ensure why the security is needed is because we want to protect the brand our customers trust. I will tell you one simple example. I think 1 year ago, there was a Citibank application onto an iPhone. And the thing is that being banking application, there is no offline storage and all. It's all that is you're storing into on their servers, and you use the application to access the features. And on that application, there is something, you enter your 4-digit PIN code and it allows you access of the entire banking transactions and stuff like that. Now what developer had done is that storing that 4-digit PIN onto the device in plain text. Because the thing is like this, you will have to launch the application, and to authenticate the user, you need something to start. Now even if you encrypt that encryption key has to be stored onto the device. Now that encryption key, again it will be again in a plain text. Now if that is also prone to hack or like prone to be stolen, encryption key has to be stored, and that is again a chain. So how will you come up with a mechanism to make sure that there is a good starting point which serves as your master encryption key, which takes you into the application, and then whatever data, whatever functionality needs to be unfolded will be done. Somebody figured out this particular flaw in the application, and the thing that they did is overnight they changed the application. And the simple mechanism that they implemented was, for example, you have a 4-digit PIN. Everyone remembers that 4-digit PIN. The combination of this 4-digit PIN is only known to the user. Nobody else knows it, neither application nor anybody onto the that particular ecosystem. So you enter this PIN, take this PIN, do a one-way hash of this, and you match this one-way hash with the stored hash. You cannot get the hash backwards. So the hash that you have will match with this PIN. The moment it matches, you know that this is the right user who logged in last time, and you take that hash and maybe some random 64-bit or 128-bit salt that you prepared, and you make a combination of it and then make an access key which actually opens up your data onto the device or onto the application. So this is the way that they had to implement it. Now think of it, who could have even imagined that storing that 4-digit PIN could have led to some of the problems, and even this was the application on App Store being so strict on like evaluating applications, how you store data and all that. Still there was this much big gap, and somebody figured it out. So had it been exposed to a community which has a wrong intention of stealing your data, or things like that, imagine what damage could have been there. And the same thing if it is with your enterprise application, that say for example a sales team has lots of pricing information, competitive information and all that is being stolen, the damage is huge. So basically you need to protect your brand, and for that you need to do each and everything that is possible to implement the security. Now again, when you go into implementing security, there is a limit to what you want to do and how much you can do. There is no end to, there is no guarantee that if you do all kind of security and it won't be broken. Probably it may be broken by the people who actually developed it, or maybe somebody else, we don't know. But then you will have to make a trade-off between what that application's requirements are and what is the severity of data and how am I going to secure it. These are the basically things. And then again, lots of other things such as like compliance to the governance, like say for example, if you are doing any PHR or EHR application, which is like basically healthcare applications where your personal health records or your entire hospital data or things like that are being stored, you need to make sure that you adhere to the FDA or CFR Part 11 requirements and things like that. So these are some of the best practices that you need to follow. Now, coming back to Android, let me confess this, that Android has not been so much entrenched or so much widely accepted into the enterprises. There are many reasons for that. But one being topmost that I can tell you is that lack of such a device which actually has a pure control onto that device from a enterprise perspective. Like what exactly enterprise wants? Your laptops, look at it. They have a control alter delete XP laptops like or your Windows laptop. Everything has to be controlled by the system administrator or like whoever your IT support team is. That kind of features were not available into Android. and probably there was no device which could say that this is the device that I want to go with. Like look at iPhone or iPad or any iOS device, people want to have it. And so first the iPhone or iOS devices took the mind share of the users, and then it was easier. The other way for Research in Motion BlackBerry devices, they were like from the day one tightly secure or like very well controlled devices. But in terms of Android, the fragmentation probably led to a level where it was not that widely accepted, or maybe it may be something with the strategic approach that Google has had. But most importantly, now is the time when Android should also be picking up. One very important reason is that Android also gives you to build your own operating system or own flavor of that operating system which you can implement. Like even if you today, if you look at like there is a Gingerbread and there is the Froyo which is on Samsung phone or the Froyo which is on HTC phone, the home screens are totally different. How do they do that? Because they have taken the operating system, they have customized it, and they can do it the way they want. Now if you take the same clue and you extend it to the enterprise world, that imagine that if I can have the control onto the OS the way that I want to manage it, in terms of like implementing all kinds of security, making like remote data push and things like that, nothing like it. That's what I want. Now the thing is that I just need the best hardware. Software already is in place. Now if you look at like current 4.x ICS versions, probably like smartphones and tablets are already covered under one umbrella. So that shouldn't be any more of the concern. Now if you look at Android as a platform, the very important features that enterprises want is basically the remote wipe. Like if you lose the data, I want the device to be wiped out remotely without having even any manual intervention. I issue a command onto the server side with something, and your mailbox, your application data, everything is just simply reset. Nothing is, no trail onto the device. All you have is just the device. So that is the kind of feature that enterprises want. Now improved security, like this is a simple thing that addition to numeric PIN, you can also do a complex passwords onto the Android phones, like I make like XYZ and some special characters and things like that. So earlier it was not there, but now if you look at like Gingerbread and even I think Froyo it is there. So those versions, if you look at it, they are coming up with all this support. Again, most of the enterprise data or most of the enterprise work is around your calendars, your emails. So having a good Exchange support and having a very good email calendaring support is something that people would love to have. Till today, if you look at it, if anybody using Android phones, up to Gingerbread, you don't have a feature that you want to move the emails from one folder to another folder. It's not there. So people generally like, it just keeps on sitting in there. I cannot move it around or things like that. So these things are also being addressed into Honeycomb or into 4.0 ice cream sandwich versions. Again, I think Rohit also mentioned about this C2DM, cloud to device messaging, which is basically making sure that you have a channel which allows you to monitor your devices, collect all the information, what has been happening onto the device, making sure that you issue the remote commands to the device, and there is a messaging, a very well laid out messaging framework put in place. And then these are some of the things that you can have like HTTP proxy for each connected Wi-Fi access points or encrypted storage cards. You have that in the operating system itself. You don't have to do anything. In the operating system, it tells you, you switch, you select one particular option, it encrypts everything that you have onto that storage card. So even if somebody takes out your storage card and tries to use it into some different phone with some different application, it's not going to work. So those things are inbuilt into the application. So as a developer, I don't care about like writing my encryption algorithms or things on top of what operating system is doing. And that is the best thing that I want to have. Now, if we look at Android from a security perspective, there are three different models that Android implements the security. One is permission-based model. The second one is real good sandboxing. And the third one is remote app management. And I will again explain you the details of this. Permission-based model is something like, as Rohit explained you earlier, or you might be even knowing that it's based on a kernel. So that Linux or Unix kernel that is at the core, if you can recall, there is a root user who has access to each and everything. And then there is a mobile user who has access to a limited functionality. Now what happens with all these permission-based models is that certain applications or certain functionalities can be given access to certain users or certain roles. from the operating system itself. Like if you root the device, you have access to each and everything. And then I'm again referring to a term called as routing of a device, which is like you take something like CyanogenMod and then you modify and you put it onto the device. So that routing is nothing else but gaining the access to the core, and then you can do everything. But without that routing, the device as it comes into the box, which you unpack and then you start working onto it, actually has root disabled. All that you get is a mobile user who is accessing that device, and that mobile user is capable of doing all that phone is offering you, like make a phone call, run applications, things like that. And then how do you interact between various different applications? Then there are content providers, there are intents that you need to define, and then you can like switch between the screens or switch between applications, or and then share the information. But the next one that I'm going to talk about is the sandboxing module that you have here. Sandbox is basically you have your own room. As an application, you have your own room. You don't look this side, you don't look this side. All that you have is this particular silo that you are supposed to work into. This is a sandbox that you have been offered. So your application cannot access any other application's data without having any permission or subscribing to any other content providers or any other mechanism that might be offered by a operating system. You cannot do that. That is a sandboxing concept. Now, doing a routing, or even in iOS terms like doing a jailbreaking, you get access to a root. So probably if you remember, just recently somebody hacked the iPhone 4S and took the jailbroken version of it, copied all the files from iPhone 4S and put it onto iPhone 4, especially to make that Siri voice enabled interface being enabled. It was one line code change, but lots of files being collected. Now, had it been not like jailbroken, you wouldn't get access to all those files. You cannot. As a normal user, you cannot. You need to jailbreak it or you need to root it. So that is the only way you can hack into it. And then again, there are APIs or there are ways that you can trick or you can find out the moment you have this kind of thing done with your phone, application can come back and say that no, this phone is compromised. And then there are tools which you can even monitor from a remote server-side framework to make sure that your phone is not being compromised with all these kind of things like being jailbroken or like rooted or things like that. So this is how Android allows you to do like sandboxing or permission-based model or even the remote app management. And if you recall, there was an instance of there were like around 40-50 some malware applications onto Google Market, and all of them were like suddenly taken out like this. Even the applications which are already installed onto the device can be wiped out. Only thing is that it's like the kind of interfaces that are available with Google, if they have been extended to MDM softwares or like mobile device management softwares, or maybe like UME provides all these facilities, much better. If Google can do it, we can do it. That means OS has that facilities. All that we need to worry about is that when exactly this is going to go public and when we can make use of it inside our applications to make sure that we give that state-of-the-art security and make sure that the enterprise applications are extremely secured. Now, this was one of the examples that how exactly you will get the permissions to the SMS if you look at the bottom of the screen. Again, we talk about remote app management. And this is how that sandboxing was, that what I explained you about, like you have an application and every application gets a unique Linux user ID. And that it has its own sandboxing, so it doesn't interfere with the other ones. There is only set definitive way that OS provides. That is the only way you can exchange the data between the applications. Like if you need to call a dialer from your application, there is a way. You cannot directly call the dialer application without having subscribed to that intent or without having that permission obtained from the user or operating system, and you can't do that. Now, still, if we consider Android as an operating system being a good candidate for enterprise applications or enterprise mobility applications, there are various different Android attack surfaces that we should be aware of. Things like, say, like single UI device versus secure sharing of UI and I/O. Like, for example, what you store onto your SD card, how you share the data between two applications. Again, the thing like Linux, again, this one thing that I forgot to mention, Android being based on the Linux, and it's not a Java based application, it's a sandbox which is basically very well protected from the operating system. Like if you look at Java applications are also like kind of hybrid sandboxing mechanism that we can call it as, but Linux being completely different, they are very well protected. And then any Java application can execute shell, load JNI libraries, or write and execute programs. So you need to be aware of these things, that even if like most of the times we install the application and operating system wants, saying that like this application requests data to your personal information, your calendar information and things like that, hardly anybody reads it. We just say accept all, trust everything, and it just gets installed. And that is where the trouble starts. Okay, now the last and important part of this presentation is basically extending this enterprise applications to the mobile. This one slide actually covers a lot of information on how exactly you can extend the enterprise applications. If you look at like on the left side, you have all your enterprise data stores, which includes like your CRM information, your SAP or your SCM or any other enterprise systems that you may have. And then there is a layer which is like enterprise backend services. Generally, all the mobile devices, they intend to take all your information or consume the services that you expose into the enterprises through web services or a mechanism which is like basically RPC or RFC or RMI kind of services, or it could be even SOAP or REST-based web services that you can use. And then in between the center, you have that enterprise application platform. If you basically look at it, there is an application layer, and there is a common services, and then there is a mobile rendering engine. Now, how exactly all these things will come into picture and how they will play with each other? The thing is, if you look at mobile rendering engine, and if you design it well, or your MIP off-the-shelf component provides it well, you can very well power or fuel your mobile web applications. And then you can have reach to multiple devices, like all that you need to worry about, like in the HTTP refer what you get, what OS or what operating system or what browser it is supporting, what resolution, kind of kundli, that entire thing that gives you, right? And then based on that, you make a decision that this is the kind of device that I'm servicing, and this is the data that I need to pick up and serve it to him. And then there could be like a common services, like say for example, I need to pick up some data from the database. So how good it is, like if you have a inbuilt kind of libraries or DLLs or whatever it could be, that easily pulls up the data from backend systems into the from the database and gives you into the devices. And this MIP is not specific to any devices, or it's specific to any operating system platforms. It could be like your iOS devices, Android devices, BlackBerry devices, even like dead WebOS devices, and so many other platforms it can serve. All that you need to worry about, that you stick to a common standard or common protocol, such as web services, in different terms of implementation. But as long as you stick to that, you have all the devices covered. And then all that you need to worry about is that write your own mobile application that brings out the best of that operating system. Like iPad gives you such a nice interface, or so intuitive, and so many people mentioned about it, right? So you make sure that that platform is utilized to the fullest. Or you go to the smartphone, which is a small screen form factor. So utilize the best available of that particular platform. That is all that you have on the device layer. That is the right side stack that you see. And then at the bottom, you see there is a mobile user and device management. I'm not sure if this is really visible, but if you look at the bottom part, there is a mobile user and device management. That is what I'm talking about, being able to manage your devices, which is basically remote wipe or remote installation, or collect the logs and tracks about like what application you have installed, whether you have been on roaming, or whether you are using a 3G connection or Wi-Fi connection, what kind of softwares or not operating system, what kind of URLs that you are visiting, and what kind of restrictions you have violated or probably adhering to. All that information, all the log can be collected. And then when you have data, taking action is pretty easy. Then the second layer, the worth mentioning here, that you have the enterprise libraries into here, which basically allows you to connect to various different business logic layers. Like, so for example, if I'm connecting to a SAP database, which is basically exposed through some of the BAPI calls to invoke some of the workflows, like say for example, order being placed, or stock being like out of stock, or things like that, or maybe transfer of stock, things like that. You can very well hook those services into the enterprise libraries. And now this is being a conceptual representation of what a mobile enterprise application platform looks like. There are lots of off-the-shelf offerings, which is like, say, Sybase has developed this very good state-of-the-art platform called as Sybase Unwired platform. They call it as SUP, which is like 2.0, which is very good, connects to various different services just like this. And all that you need to worry about is that there are plugins. You install it onto your Eclipse or your Studio. You create the business objects and right-click, say, develop code, or like, say, generate code for iOS. All .m, .h, .c files are created. All that you need to worry about is that copy that file, go to your Mac machine, embed it into your project. You just develop the UI. Everything else is already built in, just like that. The same thing is like there are various other companies like Antenna Mobility Platform, there is Pixis, there is Common Time, and all of these actually have some sort of like neat platforms that comes inbuilt connecting to various different backend systems. But then you could be a unique. Every organization is a unique. The systems that you use may not be the standard ones. There could be some homegrown systems. There could be some homegrown applications that you need to connect. So for that, you need to build your own middleware. And that middleware could be the simplest form of a simple web service that you invoke it from the device, goes connects to a definite database, pulls up the data, gives it here. That's it. As simple as that. It could be that kind of middleware, or it could be a complex one, like you start some sort of like offline synchronization or things like that, and like maybe messaging services or anything like that. So you could build your own middleware. Now I know that I'm running closer to end of my session time, and probably this is the last slide that it was there. I would like to thank organizers for giving me this opportunity.